Hi guys, let's talk about the first discrete probability distribution, which is binomial probability distribution. Binomial. There's actually many types of probability problems that have binomial probability distribution problem, which can also be said that they are having two outcomes problem, or that can be reduced to two outcomes problem. Right? For example, if you look at this table, okay, you're going to see that when a coin is tossed, the possible outcome is two, whether it is head or tail. Two outcomes. When a baby is born, so you can have either male or female. In football, you can either win or lose. The same goes for answering true/false question. You have either right or wrong. Okay. What about multiple choice question? Right. By right, we don't have two outcomes. It is four outcomes. However, if we look at in a different angle, let's say you want to look for the right answer and the wrong answer, hence it becomes binomial again. So we only have one right answer and three wrong answer. So hence it becomes binomial. So for an experiment to be identified as binomial, we can't just refer to the outcomes. Actually, we'll need to also make sure that it fulfills all of these properties. So we have four properties that need to be checked. So if that experiment, right, or that situation that we observe fulfill all of these properties, then we can later use binomial to solve to find the probability for that observation or experiment. So let us look at the properties one by one. First, the random experiment consists of an identical trial. It means that the observation or the experiment that being conducted several times should be identical. They should be the same. Alright? And the next properties, each trial or the observation should only consist of two possible outcomes. Alright, and please note that we have the terms for those two outcomes. We have the terms success denoted as S, and we have a failure denoted as F. Okay, so this success and failure, right, represent the two outcomes in a binomial. Okay, success does not literally mean success or positive things that happen in your experiment or in the observation. Right, success here actually depend on what do you want to look at. If let's say you want to look at the number of defective items or defective product, right, and that will be the success things that you want to look at, known as success in binomial. And of course the other will be failure, the other outcome. Well, you only two outcomes, right? There will be two outcomes, so one will be success, which is the one that you want to look at, and the other will be failure, and denoted as S and F. Okay, and for the third properties, we have the trial are independent of each other. The outcome of a trial is not affected by the outcomes of any other trial. So in other words, you have several identical trial, experiment, observation, and all of them should be independent from each other. They are not being affected. Okay? If this is not being fulfilled, these third properties, your result will be biased later, right? And lastly, the probability of success is constant from trial to trial, right? We denote the probability of success by P. P will be the probability for success, or the probability of the things that you are interested to look at. Okay, so the probability should be constant. So let's say on the first trial, the first observation or the first experiment, you have 0.5 as the success rate. Okay. Then when you conduct the second and third trial, the probability should be constant, should also be 0.5. Now let's look at an example just to understand about the properties, right? So let's say we have a coin that is flipped 10 times. Like you flip a coin 10 times and you want to count the number of heads. Okay, so let's check whether can we use binomial probability distribution to solve for this situation or this experiment. So there will be later 10 identical trials, right? Which is, you are just going to flip 10 times, right? Identically. So that fulfill the first properties. And then for the second properties, each trial do have two outcomes only, right? When you do one flip, you will have the possibility of having head or tail. So that fulfills the second properties. And the outcome, right, of the first flip will usually not be affected, not affect the second flip, and so on. So the flipping process, right, will be independent from each other. So yes, it by right fulfill the third one. And lastly, the probability of getting heads remain constant from trial to trial. Is it true? Yeah. Right, we have a 50% chance of getting hit each time you flip the coin. Okay, so with that, we know that this observation, this experiment, actually can use binomial to solve for its probability. Okay, so now let's talk on how to we write down the process, the binomial distribution. Okay, so the way to write down the binomial distribution is capital letter X, which is the random variable, right? Is approximately equal, which is approaching the curly line there, approaching B, stand for binomial, and we have a bracket, and within that bracket there will be the value of N and P. So that is the way to write down the binomial distribution. You can write it in a sentence, but usually in statistics, in mathematics, we put it in expression, and this is the expression for binomial. Okay, capital X approaching to B as for binomial. In the bracket you have N, which is the sample size, and P, which is the probability of success. Okay, please note that, right? You need to be clear, right? Later you need to see that not just for binomial, when you meet with Poisson or normal probability distribution later, you are going to also have this way of writing. Okay, and you really need to take note on the value that you have in the bracket. For binomial, you have N and P. This shows that these two are actually the most important value that you need to know before you can solve your particular distribution. For this case, binomial. So basically, if you don't know N or P, you will not be able to solve for binomial question, right? So that is what does it mean by this expression. Okay, now let's again look at the notation, right? let's look at the notation that being used. Okay, so we have several notation. Okay, so we have the first one, that's n, as I said, the sample size, or for this case, the number of fixed trials, how many times does the observation being done, be conducted. Okay, and then we have capital letter X, which is the random variable, the number of success in n trial. Okay, where that value of X letter can be from 0 until n, right? And we can also have the capital P and in bracket S, which is equal to small p. In other words, this is the probability of success, right, in the trials. And then we also do have Q, which is 1 minus p. That is the probability of failure. Okay, and the last one, which is the probability of X equal to the X value. In other words, what is the probability of getting exactly X successes, or the number of X successes in the n trials. Okay, so this is the formula that you can use to calculate for the probability in binomial. Okay, where we can say n, x, p, q are defined as before. Okay, and if you look at the ncx there, okay, this is the formula of ncx, where you use n factorial over n minus x factorial times x factorial. Quite mouthful, but usually we're not going to use this formula. We're just going to, calculate it using calculator or computer. Okay, so this is the formula for binomial. Okay, now rather than just looking on how to calculate the probability, among the other things that we are usually interested in when calculating probability, right, for all of the different distributions, is that we want to measure for the central tendency, which is the mean, minimum, mode, maybe the mean for this case, and for the dispersion, which is the standard deviation, variance. So let us see on how to calculate for the measure of central tendency and dispersion for binomial. Right? Refer to this table. So it's quite easy actually. Okay, the mean of x, we want to look for the mean of x, right? The formula is n times p. Okay, n times p. So, and if you want to look for variance, it is n times p times q. And of course, if you want to find its standard deviation, just square root the n